this week?
Wasn't that bad.
Yeah?
It was okay.
All right. You guys are hanging with it, huh? Yeah, that's pretty good. All right, I gotta make sure I'm recording this. I think it just went downhill. Hold on a second. Okay, I think I'm recording it. Okay, so we don't have tons of problems. Did you guys put them up, all the ones you needed?
I did, yeah.
Okay, so John has a bunch of them, but I'm gonna record it, so I'll do his. So we're gonna start with lesson 48. Of course, this is all over the board, isn't it? With what you have to know. So lesson, I have to get a pencil or something here. Okay, lesson 48. Oh, came out a green. I thought I hit white. Lesson 48. All right, so for 48, we have 10, 12, and 18. So let's see what we got here. 48, 10. Did you guys watch the dive CD and everything?
Yeah.
All right, so 10. I don't know if he does these problems like the book does, or if he does his own method. I think he's pretty close to the book the way he does it. I'm having a delay with my computer today, so I might be really sloppy. It's like not, I don't know if it's my internet or what, but it's like slow. Let's see, it's given us a green go ahead. Okay, so all you do is you basically on these, you just find the secant of 30 degrees and then you square it. And then you find the sine of 90 degrees and you cube it. So these aren't really much different than the other ones that we did. So if you're going to do secant of negative 30 degrees, you just draw your angle at negative 30 degrees like this. All right, secant is the opposite of cosine. Cosine is in these quadrants right here. All right, keep that in mind. Cosine is always in these two quadrants. Sine and tangent, on the other hand, are always in these two quadrants. Okay, did you guys get that? I mean, it's kind of, they don't talk about it much, and sometimes when you look in the answer book, you're like, what in the world are they doing? So this is your 30 degrees right here. This is your negative 30 degrees. But we're talking, secant is the opposite of cosine. So cosine is in quadrants 1 and 2. So you have to redraw your triangle in quadrant 1 like that. So you'll notice in the answer book they have positive 30 degrees. So you redraw it in this quadrant because it has to go in that quadrant. So you draw your sides. So you get 1, 2, square root of 3. And if you're going to do, this delay is going to drive me crazy. If you're going to do secant, cosine is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. And then you're just going to square that. And then the sine of 90 degrees. Do you guys understand how to get the angles that are at the called quadrantal angles? Like, do you know how to find the sine of 90 degrees? Yeah, I think it's kind of confusing. The best way that I do it is I picture it in my head. I mean, there's a couple ways to do it. If you picture the sine curve, this is the sine curve like this. So this is a sine curve. At zero, it's going to be 0. This is 90 degrees right here. And this is 180 degrees. And this is 360. And this is 270 right here. All right? So if you picture the sine curve in your mind, when it's at 90 degrees, it's at 1. So you can just kind of have that pictured in your head. The cosine curve goes the other direction, so if you had the cosine, it would be 0. Okay, that's one way. So the sine of 90 degrees, if you look on the sine curve, it's going to be 1. And then you would just cube it. The other way to do it is you think of the points going around the circle. So this point at 90 degrees, you're going to have 1, it's going to be 0, 1. And sine in the hypotenuse is always 1 there. So sine, this is x, this is y. Sine is always y over the hypotenuse. So it's going to be 1 over 1, which would be 1. So this is your sine right here. This is your cosine. So if you just make your coordinates, so if you had coordinates over here, for this one it's going to be -1, 0. This is your cosine right here. So your cosine would be -1, and your sine would be 0. So you can always do it that way, where you, that's not what I meant to write. Whoops. The sine is going to be 0. So you can either look at your curve, or else you can just look at the coordinates, and the first one's cosine in alphabetical order, second one's sine. So once you get that, then you just square it. So it's going to be 4 over 3 plus 1. And so you're going to get 4 7 thirds. Wait, thirds. Yeah, 7 thirds. 3 7 thirds. And that's all you do. These aren't much different than what we did before, except you're just going to square and cube or whatever you have to do. Okay, does that make sense? Okay, 12. 12, okay. I don't remember where they taught this. Did they teach you this kind of problem? 12?
I think so.
Okay, use the midpoint formula to find the equation of the perpendicular bisector of the line segment whose endpoints are 4, -2, and -2, 6. So first of all, you have to use the midpoint formula. So it's x, add the x's, divide by 2. So it's going to be 2 divided by 2. So it's going to be 1. And then you add your y coordinates, which is going to be -2 plus 6 is 4 divided by 2 is 2. So that's your midpoint. So your midpoint is 1, 2. All right, that's step 1. We are in lesson 48. Just want to make sure I have my solution book open so I don't make a mistake. 48. The solution book's amazing, except for the fact that it's going to be a crutch. Okay, so the midpoint is 1, 2. Now they're introducing something that they haven't, at least in the answer book, they haven't really taught this as far as I know. There's a thing called the point slope formula, which is y minus y1 equals m times x minus x1. Did you ever see that before?
You didn't teach that to us.
I know, all of a sudden it's in the answer book. In most textbooks besides Saxon, this is how you find equations of a line. So this is called your point slope formula. Point slope. I'm having trouble with this writing. It's really delayed. Formula. Okay, so what it is x1, y1 is your point. M, of course, is your slope. So if you have a point and a slope, you can write an equation of a line. So we want to write an equation of a line that goes through these 2 points and is perpendicular through the midpoint. So this is kind of a long problem. It's not complicated, it's just kind of long. So here's our midpoint right here. This is our midpoint. That's our point. So we're going to put this point x1, y1 into this point slope formula. But now we need a slope. So we have to find the slope between these 2 points. So that's y2 minus y1 over x2 minus x1. All this should be really, you're really familiar with that, right? 6 minus a minus 2 would be 6 plus 2. -2 minus a 4. So we're going to get 8 over -6. So we get -4 thirds is your slope. Now that's the slope if you're going to get it parallel, but we need the perpendicular slope because you need a line that's perpendicular to this line segment, but it goes through this point, but not parallel. So we have to do the perpendicular slope, so it's a negative reciprocal, so it's going to be 3/4 is going to be the slope that we work with. Okay, now we have our point and our slope, so we go up to the point slope formula. So we say y minus 2 equals 3/4 x minus 1. Now you can do it the old-fashioned way. Remember that way? where you have y equals mx plus b. And you can put your x, y, and m in and get b, and then you put the b and the m back in. This is the more mature way, I guess you could say, because they don't do it this way in other books. Like if you go to college, they're probably not going to do it this way, though you can get the answer easily this way. But if you put it into this form, y minus y1, and if you look at this formula, do you see how you have the m? If we would divide both sides by x minus x1, it would basically be the slope formula. See? Y minus y1 over x minus x1. So it's kind of easy to memorize. I never did it the Saxon way, but I always teach it the Saxon way. I don't know why. Okay, so then you just distribute it through, so you get x minus 2 equals 3/4 x minus 3/4, and then you add 2 to both sides, so you get y equals 3/4 x. I'm going to add 8/4 to both sides, because it's the same as 2, so it's going to be plus 5/4. And that's the answer. All right, it's just using the point slope formula, you save a step, I guess. You just plug it all in and the answer pops out, opposing to getting the b and then going back and putting it in. Okay, all right, there's another one someone asked for in another lesson, but does that take care of that for you? Did you guys get that? Who asked for that one anyway? Was that a, it's a red on mine when it prints out. Someday I'm going to have to get some color ink. Okay, does that make sense though? It's like it's a multi-step problem. You have to find the midpoint, the slope, and then find the perpendicular slope, and then put it back in. All right, new board. All right, next one is 18. What is 18? Oh, okay, this is a calculator one. Is this yours, Emily? Okay, so you hit the stat button, and then you just enter all your things, and then you push you go back in, and it'll give you the line. It will give you A, B. Mine doesn't give you R, but mine gives you A and B. Do you get that, Emily? Or do you want to walk through that? Okay, so you stat button, you add it, and then you have to do, I forget what you hit. I don't have my calculator with me. All right.
And then edit, and then you enter
Okay.
y1, which is x, and line 2, which is y, and then you click stat again, and then you click calculate, and then you go to lin, reg, and then with the parentheses ai plus b, and then you hit enter twice.
Okay, Emily, did you get that, or does that sound Chinese? Okay, you got it? Yeah, it's a weird problem. I mean, but yeah, you don't want to do that by hand. We used to do those by hand. We'd plot all those points, find the line that best fits in all those points, and then use 2 points to find the slope, and then find the y-intercept, and the calculator does it all just by entering the data in. So it's kind of cool. Okay, so let's go to lesson 49. We had a lot of lessons. We are booking through this book. We're going really fast. At some point, we'll probably slow down because it gets hard. 49, number 1. Okay, here we go with our books. I've actually learned to like these. I don't know how, but all right. So this is 2 people had this problem. I like when you guys both put numbers down, like when someone puts 2, if you put another 2, it kind of helps me to see like how many people missed it. Okay, so how many ways can we put 4 geometry books and 3 algebra books arranged in a row if the geometry books must be kept together and the algebra books must be kept together? Okay, so Emily, did you put this one? Number 2. Oh, was it number 1? Yeah, number 1. Risa, did you put that?
No.
Okay.
Not this one.
Okay, for John, whenever you have these books in a row, it's always just 4 factorial, 3 factorial, and so what it is you have your geometry books. There's your geometry books and your, What's the other one? 4 geometry, 3 algebra, but this is a math problem. Okay, you can rearrange the 4 geometry books. If these are all your geometry books, whoops, I have to go slow because of this pen thing. Okay, there's your geometry books, there's your algebra books. They're distinct books, they're all different. You can arrange these 4 factorial different ways. You can arrange it, so the way you arrange this is you can arrange it 4 factorial, and this one you can arrange 3 factorial. Anytime you're arranging books that are different, or each individual, it's going to be factorial. Like how many ways can you arrange 4 pictures on a wall? It's going to be 4 factorial. You could put this guy first and then rearrange these ones, and then you could put this one first and rearrange these. So order does matter on these. So you could also do it like this: 1, 2, 3, 1, 2, 3, 4. You could have your algebra, 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 and then geometry, geometry, geometry. So this is the same thing. It's 4 factorial times, 3 factorial times 4 factorial. So it's really 2 times, you guys know what factorial is, right? 4 times 3 times 2 times 1, 3 times 2 times 1. So there's 2 different ways you can arrange it. You can either put your geometry books first or your algebra books first. So when you multiply those all together, I'm going to look in the answer book, you get 288 different ways you can arrange them if you keep the books together. So hopefully that helps, John. Okay, number 11. Is that a rerun? Yes. So number 11 is find the equation of a perpendicular bisector. So that one we don't need to do again, right? You guys there? Okay. Okay, that's the same one as one we just did. 15. Okay, this is, you have to write an equation of a sine curve. How do you guys feel about those? Any feelings? All right, well, let's try to get them unconfused because they get a lot worse. All right, so 15 is a cosine curve because it's going to start down here. This is our 1. So it's going to start at -1 and it's going to, here's 180. I'm really bad at drawing cosine curves. Sine curves aren't quite as bad. So this is your 180 right here, and this is your 360. 180, 360. All right, so this one hits this here, and it's going to come down and hit this. Trying to get this right. Goes through 270. Goes through 270 and then ends up here. Okay, so here's your cosine curve. It comes up like this, comes down through 270 and ends back here at 360. That's sick, but whatever. Okay, and then it's on the other side as well. So a normal cosine curve, if you have the normal the cosine curve, it's going to look like this. All right? This one is flipped around. So since it's flipped, it's going to be a negative cosine curve. So you also have to find, let's see, I didn't quite draw that right. This one right here? No, it's cosine. That's cosine. This is cosine, just doesn't look good. This is cosine. I didn't draw that right again. Cosine curves, maybe if I did this a little bit, I don't know. I don't know how to fix it. The sine curves go, and they're going to call cosine and sine curves sinusoids. This is a sine curve. See that? How they're different? Yeah. Okay. This one, instead of being this line right going through here, isn't at 0, 0. So let me just draw this with dotted lines. This is at 5. Is that -5? -5. Right here, where it's going through. And so there's actually an axis at 0 here. This is actually your axis. All right, so when you're writing your sine curves, you're going to say y equals, it's going to be inverted. It's a cosine curve, so it's not going to be, this one would be y equals cosine of x. Cosine of x, or theta. You have to look and see what it is. This one, it says theta. It says right here theta plus theta this way. So we're going to use theta instead of x. So this one, if this was x, this is how you'd write the cosine curve. All right, that's how you write the equation for a cosine curve. Well, what's happening is this cosine curve, the traditional one, the basic one, the middle line, the thing that it's symmetrical around is the 0, which is the x-axis. This one, what it's symmetric around right here, is -5. So the curve moved down 5. So you say where it moves down from, which would be -5. These don't get very complicated yet, but they really get bad. So we have to really understand these. That's your, oops, is that a +5? Oh, it's a +5. Sorry about that, because I can't read. I can't see or something. Oh, that's the dot for the dotted line. So anyway, it's a +5. It's not a dot for the positive line. And then since it flips around, it's just going to be -15. So the curve goes up to, if you count from, I'm just doing a new board for this because I need to rewrite this to make sense out of it. I made such a mess out of it. All right, so let's try this again. These are kind of important, so I don't want to. Okay, so here is the axes. Let's try this again. There's the axes. Okay, the center line is at 5. So let's do this. This is 5. All right, center line. Okay, whoops. Can't draw good center lines. There we go. Okay, that's your center line. And the curve looks like goes up like this to that. Okay, so it's going to go up to 15 right here. All right, do you guys see that? Okay, so when you're writing these, you're going to write y equals, you figure out the center axis next. So that's going to be 5. It's a negative cosine curve, but you have to figure out the amplitude of it, which is the height of it. So if it's going to go up to 25, was it 25 or 20? Why did I write 25? Okay, this should be 20. This is 20. So it's going to go up, the height of it is going to be 15. So you're going to say 15 cosine of theta. So this number is the center line. Whoops, center line. And this number is going to be, it's called the amplitude. All right, do you guys see that? So if you look in your book, look at number 14. Let's just do that together real quick. I won't even draw it. So what kind of curve is that, sine or cosine? Okay, it's sine because it's starting at 0, 0. So it's starting at the x-axis on the center line at, starting on the y-axis there. So you're going to say y equals, it's not a flipped sine curve, so it's going to be a positive sine curve. Next thing we do is we write the center line, which is what?
6.
That's not the center line. Where's the line that goes right through? This is where it's symmetric around.
6.
It's 1. Where are you seeing 6? Maybe not. Page 340.
I was looking at 48.
Yeah, that would be confusing. Okay, so the center line is 1. Reese is like, no. What are you guys seeing? Okay, so it's going to be 1 plus, now you figure out the amplitude. So from 1 to 6, it would be 5. And then you would say sine of x, because it says x on it and not theta. All right, does that make sense to you guys? Center line, and then the one before it's the amplitude. We have to start shifting them. We have to figure out periods yet. Ew, these are nightmares. So you have to get this easy part to be able to get the hard part. Okay, next one, moving on. That was 15, now we are on 17. 17. Okay. They're giving you the solutions and you have to write the equation. So 17. Okay, so they're giving you the roots, which are 2 plus I. Did either of you guys have this one? Get it wrong?
I got this one.
Okay, so we'll set it up for John. So you're going backwards, so you can say x minus 2 plus I times x minus 2 minus I. All right, so and then you just FOIL it out, or you distribute it and multiply it out. Okay, John? That's it. You set it equal to 0. All right, 1721. And this looks like another John one. Did you guys get this? You got it? So these are not as hard as they look. This is an exponential function, which means it's going to go like this, or it's going to go like this, depending on whether this is bigger than 1 or less than 1. So when you do these, you just draw your axes. You make a little chart for yourself. You don't need a lot of points because we know what it's going to look like. So if we put in a 0 for x, we're going to get a 1/4 out. There's no way that this can ever hit the x-axis. There's no way it's ever going to equal to 0. There's nothing you could put in for x to get a y value equal to 0. So it's never going to cross the x-axis. All right, just let me look at this for a sec. Okay, so we have our point 0, 1/4. If this is 1, this is going to be 1/4. You just need another point to see whether it's going to rise up or if it's going to come from this direction or come from this direction, or rise up that direction. So I'm just going to put in a 2, because 2 would be good, wouldn't it? So you put a 2 in there, and so you get 1/2. So we go 1, 2, right? Everyone following me? So you get a 1/2. That's all we need. We can see that it's increasing. So all we need with those 2 points is to make your graph going up like this. That's all you need to do for that. Really, these points, all these points do is tell us whether it's going to, if it's going to increase this way or decrease down this way. And if it's a fraction, it's always going to go this way. If it's a whole number, it's going to go this way. All right, 21. Oh, we're on lesson 50. We have a lot today, really. All right, 50. All right, there we go. And maybe we'll hit some reruns. 50, number 2. Okay, I thought this one was hard. Do you guys have this one?
I didn't get this one.
Yeah, this one was tricky. You did get it, Emily? Oh, these must be your giftings, huh? Okay. How many positive numbers are less than 150? How many less than 150 are there that are all the digits are odd? Well, the hard thing about this is there's 3 cases. You can have a 1-digit number, you can have a 2-digit number, and you can have a 3-digit number. So you have to consider all the cases. So if there's a 1-digit number, how many would be odd? There would be 5. There's 5 possible odd numbers to have a 1-digit number that's less than 150. So that's case 1. So it would be 5. Case 2, you could have 5 odd in this one and 5 odd in this one. So you're going to get 25. Case 3, it has to be less than 150. So the first digit can only be a 1. There's only one possibility for that, which is 1. The second digit has to be less than 150, so you can't be 5 because 5 would be equal to 150, so it can only be 3 and 1. So there's only 2 cases for that. It would be numbers 3 and 1. And then there'd be 5 for the last case. So you multiply those together. These are all multiplied. And you get 10. And then you just add them all up and you would get 40 possible numbers. So what do you think of that, Risa?
That makes sense.
You know, these are the things that make sense when someone else does them, but they're kind of confusing. The thing is, you have to think, you have to be able to remember that there's one-digit numbers and there's two. You can't just jump to there. You have to hit all these cases and then add them up. I thought that was kind of hard. Okay. Emily, did you do that without the solution book? That's good. All right. 10. Okay, this one's weird. All right, so it says here m equals b to the a, n equals, you do? All right, so neither of you had this problem? Really? So rewrite these as log, so it's going to be log base b of m equals a, and then you would rewrite this as a log. I'm going to go fast. Log base b n equals b. And then they want us to show that log of m over n is equal to log of m log base b of m minus log base b of n. You guys really got this? Okay. You guys are amazing. Okay, so you write it over that, and so then we can say m over n equals b of a over b over c. We have to keep in mind what we're trying to prove here. Okay, log of m n, so, all right, so if we take the log of both sides of that, we would say log base b of m over n, so I'm taking the log of both sides, equals the log base b of b a minus c, because we're going to subtract the exponents when we rewrite it as a log. So we're going to get log base b m over n, and since these two bases match, you just get a minus c. And then a equals, if you look up here, log base b of m, and c, whoops, I lost a c. This should have been a c over here. And then c equals log base b of n. So that's how you prove it. I think that was kind of hard, but you guys got it. Okay, so we got that one. Now we have two 12s. So it's not as bad as it looks because two people wrote 12. Okay, what is 12? 12. 12, okay, so this one's kind of like one of the ones we did in the beginning. F of x equals secant squared x. Did I lose my place? G of x equals cosecant squared x. So we're going to find f of, so you're going to substitute. So you're going to find f of 3 pi over 4. So we're going to go to the f function, and we're going to find secant squared, and I'm going to substitute what it says f of x f equals. It's keep looking at two different problems here. 3 pi, so I'm just substituting in for the x, over 4. And g of x would be cosecant squared of 7 pi over 6. All right, this is a multi-step problem because we have to first of all change it into degrees. So you have to take 3 times 180 and divide that by 4. Did you guys, either of you have the degree? Okay. I should just go get my calculator. Then cosecant squared of, so 7 times 180, it's 10. So to convert it in degrees, you just put your pi is equal to 180, so you do 210 And then you have to do your little charty things, okay, like this, your little triangles. So secant is the opposite of cosine, right? So that means cosine is in this quadrant and this quadrant. So 135 would be over here, right? And that's perfectly legal because it's in the quadrant that cosine is in. So this is going to be 45 degrees right here. So it's going to be 1, 1, square root of 2. So the secant would be hypotenuse, which is square root of 2, over adjacent would be that, and then we square it. Does that make sense to you guys? Okay, the book doesn't do it like that at all. So they do it, just do it my way. Just figure it out, because since secant's opposite of cosine, just flip them. Instead of adjacent over hypotenuse, just put hypotenuse over adjacent. Okay, now this one is sine, so when we go to do this one, we've got a little bit more of a problem here. It's going to be 210 degrees, which is going to take us into this quadrant down here, right? Is that a legal quadrant? It's not a legal quadrant for sine. Sine has to be in these two quadrants. We can figure it out though. What's the degree going to be? 180, subtract 180 from that. What is it? I have that. 30? Yeah, I should know that. Okay. Let's see if I can make it through class without a calculator today. So it's going to be 30. So this would be, if this is 30 right here, this is going to be 1, 2, square root of 3, negative square root of 3. So this is going to be, it's going to be a positive value, so we're going to put it in this quadrant over here. I mean, it doesn't really matter. You're going to get the right answer if you do it the other way. So you get 30, 1, 2, whoops, 1, 2, 1, 2, square root of 3. So it's going to be hypotenuse, which is 2, over opposite, which is 1. So, and then you're going to square that. All right, how did they get negative 2? For they have something really weird. All right, whatever. So they get 2 minus 4, and we get negative 2. And that's the answer. All right, so stick with this way and don't do that whole thing. They do that whole thing where they put 1 over cosine like that. It's just too much work. Okay, that was 12, 24. Let's see what that is. We'll just go to a new board. It's so easy to get new boards. Why mess around with anything else? 24. Are these, do you guys get these? Are these John problems? Arc. Okay, if you have the arc cosine, this is writing such a mess today. Arc cosine of 150 degrees. When this matches this, it just pops out. It's like the inverse of a number gives you the number. So let me just see, 24. We can do this one. Let's see, 150. Okay, so if we are going to graph this, let me just show you this. If we were going to put this in here at 150 degrees, this would be 30, right? 1, 2. You don't have to do all this work. If you keep in mind, cosine is going to be in these quadrants, right? We keep going over this today. Cosines are in these quadrants, so this one fits in the right quadrant. It doesn't have to be redesigned. If it were sine, it would have to be put in this quadrant or this quadrant. When this is the same thing as writing inverse cosine times cosine of 150. If you take an inverse times the number, it would be like saying 1 over cosine times cosine of 150. These are going to cancel out, so your answer is just going to be 150. When these two match and it's in the right quadrant, that's all you have to do for that one. Okay, so 24, the second part, is sine of arc cosine of 4 over 7. So this is the one, we're not going to find the actual angle in here. We're just going to make a triangle with the sides. So if this is cosine, this is going to be your adjacent, and this is going to be your hypotenuse. So your adjacent is going to be 4, your hypotenuse is going to be 7. Use the Pythagorean theorem because we need the opposite when we're doing sine. So if we use the Pythagorean theorem, the side is going to end up being square root of 33, which isn't very nice. Okay, now we did this, so it's kind of done. So now we're finding the sine of theta. Here's theta. So it's just going to be opposite. So it's going to be the square root of 33 over 7. And is that the final answer? Yes, that's it. All right, so you use what's inside of here just to set up your triangle so that you can find the sine of it. And that's all there is for that. All right, and 30, we're not going to do that. We never have anything on 30 on test or anything. Okay, next one is lesson 51, number 11. 5111. Okay, so these are equations. This is what we actually learned in this. I like the equations. Square root of 3. Whose is this? Okay. Okay, so if it's an equation, you just have to just solve it for the what's that called? The function. So we have cosecant of theta equals -2 over the square root of 3. So you have to isolate the trig function like that. Okay, once you isolate it, cosecant is the opposite of sine, so this is going to be your hypotenuse over your opposite. All right. Whoops, I'm having trouble writing this. Okay, so you're going to make your thingy do, and you can tell if I did this. Here we go. Opposite hypotenuse is -2, so you can't have a negative hypotenuse, so it has to go down here like that. So that means your opposite is going to be negative, so it means it's going to be down in this quadrant down here. So the opposite is going to be the square root of 3, and the hypotenuse is going to be 2. So what's this angle going to be? Which angle is across from the square root of 3? 60. Okay, because it's sine, it's in this quadrant or this quadrant. And you can either put, well, let's see what they put down for an answer. You can either put -60, 51, number 11, which they don't. So, okay, this is a little bit different. So you have to figure out what this is going to be. If this is going to be 60, if you go around like this, okay, that's going to be 300, right? All right. This one has nothing to do with which quadrant is. The quadrants matter when you're figuring out it. Yeah. I don't know what I'm talking about right now. So this is going to be negative square root of 3. And the other quadrant that it could be in is this one, because you would have also negative square root of 3 down here. Now, what do the directions say? They have different directions. 11. Yeah, see, this one's saying solve the following equations between 0 and 360 degrees. So you want anything that can fit in between 0 and 360 degrees. So this is going to be 60 here. So the other angle is going to end up being 240. So you need to get all the angles that this works for within 360 degrees. So it'd be 2. So make sure there's most likely always going to be 2 for between 0 and 360 degrees. Okay, and the last one before we talk about your test. 27. Okay. 27, what is that? Okay, this is the same thing as we just did, but these are always tricky. Okay, this one is cosine of the arc sine of 3 over 4. So you have to do the triangle, 3 over 4. So cosine of the arc sine. So this is going to be, if it's sine, it's going to be opposite over hypotenuse, like such. So it's going to be 3 over 4. And what's this one going to be? Just square root of 7. And then we do the cosine. Here's our theta now. So we did all that so that we could figure out our theta. So now we're going to find the cosine of theta, which is adjacent over hypotenuse. Reese, does that make sense? 27, let me see if I can find it. This is lesson 51. Lesson number 27. Okay, so that is that, and then we have to do part B. Okay, this one looks fun. The tangent of the arc sine of -5 over 7. Oh, there's 3 parts to this one. Yay. Okay, so this is the same thing. You can't have a negative hypotenuse, right? So this is going to be your opposite. This is going to be your hypotenuse. This is tangent, which has to be in these 2 quadrants. Okay, tangent lives in these 2 quadrants. So its opposite has to be negative, so it's going to be down here. We do our triangle. So our opposite is -5, our hypotenuse is 7. We do the Pythagorean theorem and we get 2 square root of 6 for this side. Right? Okay, and now we do the tangent. This is our theta. So we use this fraction in order to get the triangle, to get the theta. So tangent of theta is going to be opposite over adjacent. 2 square root of 6, and then we can't leave it like that. We have to rationalize. So we get -5 square root of 6 all over 12. And that's your final answer. Yikes. Okay. Yeah, there's a part C. Because we have to do part C's here. Okay, so this time we have the arctan of the tan of 210. Now I told you before that the arctan and the tan cancel out, so you should get 210. Well, the problem is it has to be in the right quadrants because the tangent ones, they limited it so that we don't have too many answers to these quadrants right here. So if you figure out the tangent of 210, it's going to be in this quadrant, which is an illegal quadrant for tangent. So 210, so this one's going to be, what is it, 30? 30. All right, but we can't leave it in that quadrant. Is it 60? Okay, 60. So this would be, if it's tangent, it's going to be, you can actually, you can kind of leave it here and do it by hand. This would be, let's see, this would be, help me here. Yeah, Risa, where'd you get 60?
Oh, no, the other angle is 60. The angle next to it.
This one.
Yeah.
We don't care about that one.
Yeah.
Okay. All right. 1, 2, square root of 3. So this is going to be negative. If it's tangent, it's going to be negative. And this is going to be negative because of where it is. So that's going to end up being positive. Hold on 1 second. But it has to be in the other quadrant. So it's really going to be, since it has to be, it's going to end up being positive. A negative over a negative is positive, so it's going to end up being in this quadrant. So this is going to be 2, 1 square root of 3. So this angle is then going to end up being 30 degrees, not 300. All right, 30. The reason it can't be, usually these just cross out, like I was telling you, these just cross out and you get 210, which would be fine except for it's not in the right quadrant. It has to be in these quadrants. So that's why it has to be the 30 and not the 210. So, okay, so all you have left for this year is to take a test. And I'm going to have to send you the test. But I want to send you a study guide for this test because it's starting to get really complicated. And there's also some that are like here's one. At the microscope sale, Conrad's sold M microscopes for $D. I'm gonna take that out and put a different kind of problem in there. So I'm gonna do this now. I'm gonna send you the study sheet and the test. So I just have to rewrite these. There's 2 of them on here to top it all off. So I have to rewrite those and put them in for you. So, and then I'll give you a study sheet. You don't have to do the whole study sheet if you know how to do them, but it'll just give you an idea of what kinds there are so you can look them up and try to be better prepared for them. All right? All right, we finished early today, which is really unusual. So it's a before Christmas gift. That's bad. That's really sad. So anyway, so I'm going to do that. I'm going to send your test within the next hour. The test in the so if you want to do that today or the study guide today and then the test tomorrow or whenever you want to do it, just try to get it done. Don't put it off until after Christmas. You'll forget everything. All right? So that's it. You're welcome. Have a good holiday. Have a good Christmas. That's terrible. I said holiday. Have a great Christmas. I'm like brainwashed. So have a great Christmas. All right, we'll see you guys. All right, bye-bye. Look under my bathroom sink.